All right, so how would we do something like this, right? Uh, if we just looked at this side of the molecule, we said, oh, we have an ester right here, we have an alcohol right there. What did we do? We reduced that ester to the alcohol. But the problem is we have, how would we do that? Reducing agents we've used are sodium borohydride, lithium aluminum hydride, hydrogen with palladium and carbon, the catalytic hydrogenation. What's our problem here? So think about that for a minute. Yeah, you wrote it down. Our problem is that we have multiple carbonyls. And the one that we want to reduce, the ester, is actually, which one's more electrophilic, the ester or the ketone? If ketones are more electrophilic, esters are less electrophilic than ketones. So if we treated this with something like sodium borohydride, lithium aluminum hydride, either of them, we are not going to be able to reduce this without also reducing that. So we need some way to selectively reduce just the ester without reducing the ketone. So what did we just talk about? Acetals, right? And acetals form on ketones or aldehydes. They don't form on esters or more oxidized carbonyl types of derivatives. So it turns out we're going to use our acetal as a protecting group here. So we learned about terbutyl dimethyl chloride as a protecting group. Acetals are also a protecting group. So essentially, what we have to do is remove the carbonyl functionality from that ketone. To do that, we will add our diol, so that's going to put the acetal on. We have to have acid catalysis. We'll put our solvent in there. It was benzene. And then the other thing that we need, if we want to really force this forward, is the Dean-Stark apparatus. So we'll just write Dean-Stark. So all those things together should form the acetal and the ketone, leaving the ester, as the esters are less electrophilic. This is going to add to that instead of that. So that would provide us with this acetal and the unprotected ester. Now that we have the unprotected ester and the protected ketone, we can now do the reduction we wanted to do. We wanted to reduce that to the alcohol. The way that we do that is lithium aluminum hydride. And we will also put the solvent in there. We'll use diethyl ether, or an aprotic solvent. That would provide us with the alcohol functional group we wanted. And then we just have to remove the acetal. Remember, the acetal arrows were equilibrium arrows, and we put them on with the same stuff that we take them off with. All we're going to do is have an excess amount of water with some acid catalysis. The acid will protonate that acetal. It'll leave, forming an oxonium ion. The water will add in, and will form that ketone, and the ethylene glycol, the OH, CH2, CH2, OH, will be formed as a byproduct. So this just shows how acetals are really useful as protecting groups when we want to modify more oxidized types of carbonyl derivatives and not oxidize the more reactive ones like ketones or aldehydes. Yeah, pretty cool.